Hello. Today we're going to talk about lines of best fits and a little bit more about scatter plots, but we're specifically going to focus on the lines of best fit. So here's your warm-up for today. Pause the video, work this out on your paper, and then when you unpause, we'll go through it together. All right. So on a scatter plot, your independent variable is always the one that's on your x-axis, right? So your independent variable is the number of boxes of paper ordered. And again, you know that it's the independent variable because that's always your x. And then your dependent variable is always the y. So the dependent variable is the cost for each box of paper. And again, you know that because it's the y. So number 2, what type of correlation does this scatter plot show? So number 1, if I look, the kind of line going through the middle that we talked about last class, or in other words, the line of best fit, is a straight line. The pattern here is a straight line. So it's a linear pattern or a linear correlation. And if I go down this line from left to right, it's moving downwards. So it's negative. And then remember, strong, moderate, or weak, you say to yourself, well, how close are those points to the line? They look like they're pretty close. So I would say it's strong. All right. Okay. So let's talk about our agenda for today. You're going to write the equation of a line of best fit, and then you're going to use that line to make a prediction. We're going to do some multiple choice practice, and then you're going to do some practice on your own. All right, so on the scatter plot to the right, the line of best fit is drawn for you. So again, you can see the blue dots, that's the scatter plot, and the blue line is the line that draws or that goes through the middle. And remember, a line of best fit kind of follows the pattern. It has about half of the points above and half of the points below. And so ultimately, we want to write the equation of this line. And in order to do that, we have to identify 2 points that are on the line. Notice the words on the line are bolded because they have to be points where the line intersects the grid marks exactly. So this point here that's kind of highlighted red is on this blue line and it intersects the grid marks exactly. That's the point 2, 20. And if I look through for another place where the line goes through grid marks exactly, it looks like it goes through here. And remember, I'm not looking for where the line intersects one of the blue dots, right? I don't care about whether or not the line is intersecting the blue dots. I care about where the line is intersecting the grid marks. So it's kind of like when I get to this point where I'm writing the equation of the line of best fit, it's kind of like I forget about the blue dots. I only look at the line. I pretend the blue dots aren't there at all. So this line goes through this point right here. So this is the point 6, and if this is 30, this is 40, this is 35, right? So it's the point 6, 35. And now I'm going to find the slope. So we've been doing this for a while. You're going to plug in 35 minus 20 over 6 minus 2. So this is 15 over 4, right? And now I can't reduce that or simplify or anything, so I leave it. In part B, it says, caution, the y-intercept is not easy to find here. Why not? So the y-intercept is where the line crosses the y-axis, right? Here's the y-axis. Do I really see where the line is crossing this y-axis? I don't see that at all. And the other thing, more importantly, really, is that there's what's called a break. This thing right here is called a break. And so you can see like the axis typically goes up by 20, 25, 30. So it typically goes up by 5s, right? But here we go from 0 to 20. So a break means that we're kind of like missing all those numbers in between 0 and 20. So you can't find the y-intercept here. You can't find it, or you can't like see it. So in order to write the equation of the line, I'm going to take my slope that I calculated up here, and then I'm going to pick one of these points. It doesn't matter which one. And I can plug into y equals mx plus b or point slope form, whatever. So we've done this a bunch of times. Y equals mx plus b. Here's x, here's y, and here's m. So my y value that I chose, is 20 is equal to 15 over 4, and then x is 2, sorry. So x is 2 plus b. Now, here's the bad and the good about scatter plots. Scatter plots and lines of best fit, a lot of times these equations are going to be ugly fractions, really tricky like to use. So that's the bad thing. The good thing is that we want you to use decimals. So when you are solving for these equations, you're going to use decimals. You're going to type in like 15 divided by 4, and I get 3.75. You're going to multiply that by 2, and I get 7.5. So this is 20 is equal to 7.5 plus b. And then when I solve for b, I'm allowed to use this decimal. So 20 minus 7.5 is going to be 12.5. So that's my b. Now my equation, I need to take my b and my m. Y is equal to 15 over 4x plus 12.5. So there's my equation. Now part D, it says use your equation to predict the number of active clusters in 2010. So the question is, what should you plug in for x? So 2010, that's the year, and I'm looking for the active cluster, so I'm looking for y. So I know I'm going to plug in for x, but x is the years since 1990. So if it's 2010, we need to figure out how many years it's been since 1990. So we need to actually subtract. It's been 20 years. So you're not going to plug in 2010 for x, you're going to plug in 20. So you're going to do y is equal to 15 over 4 times 20 plus 12.5. And 15 over 4 times 20 is 75. 75 plus 12.5. Add them together, 87.5. And then write a little sentence. In 2010, there are 87.5 active clusters. Make sense? All right, so that's our first example problem. Let's do another one together. Oh, sorry. Okay, so again, on a scatter plot, you have the line of best fit drawn for you. You have the hours spent studying. This is your X. And then you have your test score. Oh my goodness. Your test score is your Y, right? So you need to identify 2 points on the line and then find the slope. So again, remember when you're writing the equation of the line, we don't care about the blue points. We care about what grid marks is the black line going through. And you can see these two kind of black points on the line here. It's going through this point 4, 70, and then through this point 8, 90. And so we need to find the slope. 90 minus 70 over 8 minus 4. And this should be review. We've done this a million times, right? So the slope here works out to be a nice number, 5. Now we need to write the equation of the line. So again, we're going to pick a point. We've done this a million times now too. This is X, this is Y. You could pick the other point if you want. And we're going to plug it all in. So Y equals mx plus b. So my Y value was 70 in that point. My M that I found is 5, and my X is 4. And now when I solve for B, I have to multiply 5 times 4 and then solve for B. So we're going to subtract 20 from both sides. And so B is equal to 50. But now my equation, oh my goodness. My equation is going to be Y is equal to 5x plus 50. I have to put it all together. So now in part C, it says use your equation to predict the test score if someone spends 9 hours of studying. So again, 9 hours of studying. Think about, is that X or is that Y? So hours of studying is X, right? So this is telling me that X is 9. So we're going to plug in to this equation. So 5 times 9 plus 50. Y is equal to 45 plus 50. So Y is equal to 95. So interpreting it, if someone spends 9 hours studying, they should get a 95 on the test. All right. Okay. So now you've done a couple problems where you had to write the equation. Most of the time when you see these kinds of questions, they're going to be in the form of a multiple choice practice problem. So we're going to do some of these practice problems together. So number 1, a baseball coach graphs some data and finds the line of best fit. The equation for the line of best fit is this. This is the equation he comes up with, where X is the number of times at bat and Y is the number of hits. So how many hits should he expect from a player who is at bat 175 times? So the person's at bat 175 times. Let's look how they define the variables for us. They said X is the number of times at bat, Y is the number of hits. So you have to think to yourself, is this X or is it Y? They're at bat 175 times, so X is 175. So we're going to take X and plug it in. So 175 in for X. And we're going to solve this equation for Y. So you're going to use your calculator. And if I multiply 0.32 times 175, I get 56 minus 20.51 is 36.51. Right? So if I look at my answer choices, the only one that makes sense is this, choice A. Right? All right, let's try another one. Why is it not letting me go on? There we go. Luke wants to know if he's improving his skill on the cello. He creates a scatter plot and drew a line of best fit. Which equation would best represent the line of best fit? So they actually give you the points here already. They label these 2 points that are on the line for you, which is so nice. So you really just have to plug them in and write the equation. So you're going to find the slope first. 1.5 minus 8 over 5 minus 2. So 1.5 minus 8 is negative 6.5 over 3. And remember, I want you to convert that to a decimal. So when I plug that in, I get negative 2.17. And then I pick either point. I'll just pick this this one right here. So this will be x, this will be y, and I plug in y equals mx plus b. So y is equal to 8, m is equal to negative 2.17, x from the point is 2 plus b. And hopefully you're noticing we're literally doing the same thing over and over. This was the same process with parallel and perpendicular lines. And every time we wrote equations, it's the same thing. So now to solve for b, we take negative 2.17, we multiply by 2, and we get negative 4.34. Add 4.34 to both sides, and you get 12.34 equals b. So your equation should be y is equal to negative 2.17x plus 12.34. When I look at my answer choices, A is the closest to that, right? So that would be my answer. All right. Before we move on, let me talk about some test taking strategies. I probably could have figured out this answer without actually doing all this work and writing the equation. A couple things I want to notice, or I want you to notice. The slope. The slope here is negative, right? So right away I can cross off any slope that's not negative. So right away I can cross off b. And then if I look at the y-intercept is going to be somewhere up here. So if I look at the three remaining y-intercepts, 12.39 and negative 9.35, I can eliminate this. It's definitely not going to be a negative 9.35. So now I've narrowed this down to just choices A and C. So if I just plug in and find the slope, I can then knock out choice C and say my answer is A. So a lot of times knowing these test-taking strategies is really helpful. But if that's confusing to you, that's okay. You just work out the whole thing, no big deal. All right, number 3. Jared collected data on the ages and heights of a random sample of elementary school students. If he plots the data on a scatter plot, what relationship will he most likely see between age and height? So think about it. What's the independent, what's the dependent variable? If we have age and height depends on age, right? So this is X, this is Y. So this is kind of what your graph is going to look like. Now think about what's going to happen when you're in elementary school. As you get older, think about like a kindergartner versus like a 5th grader, like a 1st, 2nd, 3rd, and a 4th grader. What typically happens? The 5th graders are typically taller than the kindergartners, and the 1st graders are typically taller than the kindergartners, and the 2nd graders are typically taller than the 1st graders but shorter than the 3rd graders, right? So generally, you have a positive correlation. As age increases, height also increases. All right, number 4, Mrs. Chang made a graph to represent the time her students spent studying for their tests and their actual test score. What's the correct equation for the line of best fit? So this is just like number 2 that we did a few minutes ago. The nice thing is that they give you the 2 points. You just have to write the equation. So 90 minus 65 over 25 minus 7. So this is 25 over 18, right? Now that's kind of like an ugly fraction. So I'm going to plug that into my calculator and get a decimal. So 25 over 18 is 1.388888. So I'll round it to 1.39. So again, kind of like test-taking strategies. Think about what we talked about before. If my slope is 1.39, I can eliminate C and D right away. And I can probably tell by the y-intercept that the answer choice is going to be A. Because wouldn't make sense for the y-intercept to be negative 84? Doesn't look like it. But let's double check Let's use this point here. I'll call this x and y. Y equals mx plus b. So 65 is equal to 1.39 times 7. So 1.39 times 7. Use your calculator. You get 9.73. And then solve for b. So 65 minus 9.73. 55.27. So my equation, y is equal to 1.39 plus 55.27. And if you do some rounding, you end up getting letter A. All right, number 5. The graph shows the weights of dogs and the time it took the same dogs to complete an agility course in seconds, which shows the line of the of best fit for the data. So again, you want the line that kind of goes through the middle of the data points. It should have about half the points above, half the points below. It should kind of follow the trend. So hopefully you can tell that it should be letter C there. And then number 6, at the Happy Paper Company, more boxes of paper you order, the cheaper the price you have to pay. The lower the prices charged per box of paper to different companies ordering various quantities of paper. Using line of best fit, if your company wants to pay $5.05 for each box of paper, how many boxes of paper should be ordered from the Happy Paper Company? So I can use the graph here. They want to pay $5.05. If I look, that's the cost, right? So here's $5, here's $5.10, here's $5.05. So if I go here, where does this intersect? At 3.5, right? So it's 3.5, but it's measured in thousands. So in other words, 3,500. Answer choice C. Now I could have written the equation of the line and then plugged in to solve, but I could also just use the graph that's in front of me. All right, guys, that is it for today. Thank you so much for watching. Let me know if you have any questions.